No. Okay, that's just, you guys all know that we're being recorded now. Let's see, I'm going to hide non-video participants. I'm going to turn off my camera. All right, I'm starting the webinar now, so hold for 30, please, and good luck.
Well, good morning or afternoon or evening, everyone. We welcome you to the ISOP Fall Seminar Series. It's the first of our webinars. ISOP, as you will know, is the International Society for Presbyopia. So it's been putting these conferences normally by the European ERCS meetings, but these years it's been webinar style. So we are really grateful for the continued support of our sponsors. And we have a very interesting session today talking about visual perception and questionnaires. In everything we do about presbyopia, we are manipulating the optics, we are creating different ways to produce accommodation or pseudo accommodation. But of course, we care about vision of the patients. We want to provide the best vision. And therefore, it's important to assess their visual perception, and it's important to gather subjective feedback. And this is what the webinar it is today. We have a really multidisciplinary cohort of speakers today, ranging from neuroscience to ophthalmology to visual science and optometry. And that goes along with the spirit of ISOP, which is a society and a cycle and sessions that really address the multi-dimension components of the problem of presbyopia. And therefore we have clinicians, we have scientists, we have the industry. So again, I welcome you on behalf of all the chairs for a very exciting session ahead. And I would like to thank the sponsoring companies again. So with that, I would like to first introduce our first speaker, who is Michael Webster from the University of Nevada in Reno. He's a visual neuroscientist, also a great friend and collaborator, and he will be speaking on perceived blur and neural adaptation.
Okay, thank you, Susanna. I'm going to share my screen now and hope people can see it. You see my slides okay?
Yes.
Okay, I want to thank Susanna and the organizers for inviting me to speak today, and I hope everyone's doing well. My own work, I'm basically a psychologist, so I'm really interested in how people see and experience the world. And with Suzanne, over the many years now, we've been looking at how people perceive their blur in their visual system. And specifically what we're interested in is how your perception of blur changes depending on the blur you're exposed to. And so this is a question of how your visual system is adapting to the situation that it's in. And adaptation turns out to affect almost everything you see. So for example, if you were just to look at the center of these 4 squares here, in a matter of seconds, each part of your eye is adapting to the average color you're exposed to. And if you keep looking at the center of these squares, and when I switch to the next slide, you might see color after images. So the point again, it's just in a matter of seconds how you're perceiving the world can very dramatically change. And we know that this adaptation, which has been widely studied to color and light, happens very early in the visual system, right in the retina. But there are all sorts of other adaptation effects that happen throughout the visual pathways. So we know, for example, that you can adapt to very complex properties like how things are moving, or even abstract things like the appearance of someone's face. And so the first point, again, is that this adaptation is really just a ubiquitous property of how your visual system works. And the second point I want to make is that the adaptation is adjusting not only to the changes in the world you're in, but also to changes in yourself. And so, for example, as you know, the lens gets yellower as you age, and because of that, the light reaching your retina dramatically changes throughout your life. If you didn't adapt to these changes, then the world should look really yellow as you become older. But in fact, we know from lots of studies that older adults describe color in the same way as younger adults, even though they're effectively seeing it, colors through a very different visual system. And we've even looked at this in cataract patients. If you remove their very dense and yellow lens and replace it with a clear lens, then over time, they will actually change their perception of color. So they'll start to describe color and experience color the same way they did through their cataract, now through their intraocular lens. Again, because they're being calibrated to the world, they're effectively seeing the world the same way, even though their visual physiology has completely changed. The third point I want to make is just that this adaptation has many functional consequences, everything from controlling sensitivity to maintaining constant appearance and allowing you to code information more correctly. And so there's lots of reasons why we expect the visual system to be very adaptable. And so anyway, this brings us to blur and the point that even things like the optical properties of your eye, you probably are strongly adapted to those. And we've been studying this again over many years now, looking at how you would adapt to changes in the blurriness or sharpness of images. To think about this, I'm really interested in how the neural system responds to blur. So if we think of blur optically, it's sort of a one-dimensional or one-sided function. It's either focused or it gets more blurred. But if you think of it at the neural level, focus is really the center point of the response, as things can either be too blurred or too sharp, depending on how your visual system's calibrated. And in the experiments we do, usually we're just asking a subject, when does this image look focused to you? Does it either look too sharp or too blurred? And so here's an example of these effects. If you stare at the center spot here, then these two images are physically focused. But if I switch now to this slide, then the image on the left has been blurred. The image on the right has been sharpened. And again, if you keep fixating the center, when I switch back, the image on the right might look briefly more blurred to you. And the way we study these effects, again, is basically to ask people to make these focus settings after adapting either to sharp or blurred images. And you get really strong after effects very rapidly, regardless of the type of image that you're using. And we know that this blur is basically producing a renormalization of your spatial sensitivity. So it's not that you just become less sensitive to blur, but what actually looks focused to you depends on the image or the amount of blur you're looking at. Well, with Susanna, we've been specifically interested in asking, are you actually adapted to the blur specific to the optical aberrations of your eye? So we've looked at this both for lower order aberrations like astigmatism, and find very strong effects of the blur. Not surprisingly, is really selective for the orientation of the blur. And we've also looked at higher order aberrations, which she's able to do through her adaptive optic systems. And this is something that was actually first looked at by Pablo Artal, who showed that people prefer or think the image quality is better when they're seeing it through their own optics. And we've done a series of studies showing that too. So even people that have very different amounts of blur, what looks correctly or subjectively in focus to them is really predicted by the amount of blur in their own eyes. And if you change that blur relative to someone's individual eye, then they will readapt to that blur. Finally, they've also, Susanna's group has shown that in fact, the two eyes often differ in optical quality, and the perceived blur really depends on your better eye. And even these adaptation effects, whether you're looking through your better or worse eye, are really driven by the optical properties of the better eye. So all of these together suggest that this adaptation is really, to blur is really happening at a cortical site after the information from the two eyes converges. Now, there's a number of ways where this adaptation can affect perception, and the kinds of things that I look at are happening at very short time scale. So again, just in a matter of minutes, your subjective focus can change. But there's also evidence for very long-term adaptation that's been studied now for a lot of different conditions like astigmatism or keratoconus eyes, and showing that people, again, are really adapted to their own optical properties. And it's also been shown, really starting with Pesadovs and Brennan, that even at relatively short times, a matter of hour or two, you can start to see changes in visual acuity too. So it's not just your subjective experience of the world, but even sort of the your performance can change over time. So these adaptation effects can basically really profoundly affect the way people experience the world. And finally, there's even interesting results to suggest that you can actually learn to adapt. So this has been found, for example, when people repeatedly put on an optical correction, they seem to get quicker at adjusting to it. And this may, in fact, reflect a sensory adaptation. So they're learning that, or possibly even storing different calibration states so that the minute they put on or see the world through a new system, they can correct for that. So just to end, I want to talk about the implications of this specifically for presbyopia. And the first is the good news that despite all the horrible things that happen, your brain seems to remain pretty adaptable over time. So we found that older adults adapt about as well to blur and other features as younger adults. And this is probably because this adaptation is so important for calibrating visual sensitivity. We've also found that older adults, however, when they're probably are adapted to their presbyopic correction. So when they remove that, their perception of sharpness is different from younger adults. And finally, people like Susanna's group have started to look at what happens specifically for different presbyopic corrections. So her group lab has shown, for example, that if you're adapting to simultaneous vision and the blur introduced by that, then you can see adaptation that's specific to that. So just to summarize again, this adaptation is really just a very general property of how your visual system works. It's not at all surprising that we adapt to blur because we basically adapt to almost everything that we see. And so these adaptation effects have very strong implications for trying to understand exactly how your vision is going to adjust as you age and how it's going to adjust for different visual corrections. And so I want to end on that and thank the organizers again for inviting me. Thank you.
Thank you so much, Mike, for a wonderful presentation. So I think we have time for some questions from the audience. So they can be either addressed through the Q&A in the Zoom, or you can raise your hand. Yeah, Dan has a question.
Yeah, I have a question. So some of us have spent a lot of time trying to correct for all the different aberrations and blurs and those kinds of things. Can you draw any conclusions about some level of correction? If we all adapt to our blur and we see better through our blur, maybe we don't need to be worrying about correcting all these aberrations.
So that's a great question. So the effects that I look at are mainly your subjective experience and not necessarily your acuity. And again, it's been found that even acuity can change with adaptation and show improvements, but there's also obviously some hard limits to acuity, like in terms of the optical blur and receptor sampling and things. So there's really only so much variation you can introduce in that. So I would say that the corrections have an enormous obvious benefit in improving spatial sensitivity. They can have surprisingly little benefit perhaps in changing just your subjective experience of the world. And those are very different things, again, that what looks focused to you is not necessarily, again, seeing the finest detail. It's just your sort of impression that your visual system builds of what looks correct in the world. And blur normalizes and adapts in the same way as other visual properties. Again, what looks gray to you is really just a matter of the color that you're exposed to. But your color discrimination isn't necessarily improved. It's just your subjective experience of color.
But if you correct somebody's aberrations, defocus or whatever, then that presumably they would go through a period of adaptation where they would actually adapt to that better optical system. And then maybe they would have a higher level of acuity or something at that point.
Yes, and certainly I think it's, there's still surprisingly little information about this, but again, anecdotally, people report that when they first get a new pair of glasses, it takes time to adjust to them. And the prediction of this is that if you corrected someone's blur, then the world's actually going to look too sharp to them and might be uncomfortable for that reason. And they will take time for them to readapt to that.
Yeah.
We have a question from the audience. I can read it from the chat. It's a very interesting question. Professor Webster, you mentioned that adaptation occurs at the cortical site post-combination. How is adaptation influenced by anisometropia?
So again, Susanna's group has shown that if there's differences between the two eyes, then it's really driven by the performance of the better eye. And it's quite remarkable that, again, we can show with adaptation that this is really a neural calibration. It's not just a subjective experience. So if you show someone a particular blur level that they say looks focused, that's also the stimulus that doesn't change their state of adaptation. And it turns out that is driven by the stronger eye. So when there is a difference between the two eyes, even the calibration for the poorer eye, vision through the poorer eye is really dominated by the better eye.
Yeah, and Ethan Mengel had a question. This from I hear from Chris.
Oh, he
So
raised
I
his
have-
hand. He raised his hand.
Yeah,
Okay.
in
We
the
can-
meantime, I have a quick question.
You there, Ethan?
Oh, there is.
Yes, I'm sorry. My question was answered. Thank you.
Okay, thanks.
Yeah, and we have two other questions here. Will there be any difference when we measure the adaptations from different levels of blur using optical defocus induced with lenses versus the defocus induced by other computerized methods?
So that's a fantastic question. So obviously, the work I do is actually simulating blur on a computer. So I don't, whereas Susanna's group has the ability to actually change the retinal image in ways that directly characterize how they would be blurred by the optics of the eye. I think for the most part, they're similar, and that it's, I think a really important point about adaptation is that adaptation is really calibrating your mind to the outside world, and however the world is changing, you're going to adjust to that. So whether it's a change introduced by yourself, for example, in the properties of your optics or the rest of your visual system, that's going to adjust to the characteristics of the world in the same way as if the world itself had changed. And to me, that's really important because it suggests that even people who have very different optical quality, they should tend to have a similar experience of the outside world because they're both adapted to adjust their own visual system to the outside world. And conversely, if the world itself had changed, then and people lived in different worlds, and they're going to start experiencing blur and other aspects of the world differently.
Yeah, and that connects to another interesting question, which is on how fast people adapt, and there's people that adapt faster than others. And I think this is very relevant for clinicians, right? When they're giving a patient a prescription, and they discuss with the patient how long it will take them to adapt to a new correction.
So that's a fantastic question that I get all the time, and I'm always embarrassed that I can't give a good answer to it, but we know that this adaptation happens over very many different time scales, and that makes sense theoretically that the world itself can, and you yourself can change over many time scales, so it makes sense to build a system that can really track different rates of change. Another really important part of that is whether there are individual differences in adaptations. For example, we don't find group difference clearly between older and younger adults, but there probably are very large individual differences. We don't even know, are those sort of generalized differences in adaptability, or might they be specific for different types of adaptation? And so I just think those are really important areas that are still open to study.
Yeah, fantastic. And probably the last question before we move on. When you say blur driven by the better eye, the person asks whether you mean the eye that has better visual acuity, or that is the dominant eye. What do we mean by the better eye?
So specifically by the eye with better optical quality.
And yeah, that's very interesting because it really has connections with monovision and how to pick up the dominant eye for a correction in monovision. So very last one, responding to a certain degree of residual aberrations, which kind of patterns are a stronger, better adaptation after refractive or cataract surgery?
Which type of what?
Patients, which kind of patients are a stronger, better adaptation?
I think there's different parts of that. Again, we really don't know a lot about individual differences in the neural responses to blur. There have been studies that have looked at that and shown that there is quite wide variability. And it's very possible that some people will be much more receptive to corrections just because they're literally neurally more adaptable. And that's something I think is a really important area that hasn't been fully addressed yet.
Mm-hmm. Fantastic. So I think we can, thank you so much, Mike, and please stick around if you can for the final discussion. We have our next speaker, Konrad Pesudovs. He's from the New University of New South Wales, so really staying late for us today. He will be discussing quality of vision through questionnaires.
Terrific. Thank you very much, Susanna. So if we consider any outcome study of cataract or refractive surgery, we know we can measure the optics of the eye in a number of different ways. We can measure vision in a number of different ways, and we can measure people's attributes in different ways as well. But when we look at the correlation between these measurements, invariably it's quite poor. You know, optics correlates poorly with vision, and vision poorly with the person. And obviously there are reasons for this. We've just heard all about adaptation, and that's got to be a key factor in damaging these correlations. But also these factors are inherently complex at each level. And really, if you want to know about what's happening at the person level, you need to measure it. So when you do that, you get what's called a patient-reported outcome measure, or a PROM. And this is a measurement of the impact of disease or treatments from the patient's point of view. Now, PROMs can be questionnaires or something called an item bank, which I'll touch on briefly. I want to cover a bit of background, though, because not all PROMs are the same. And the really important issues are what they measure and how well they measure it. So I want to spend a little bit of time on this. So firstly, let's be clear about what it is we want to measure. When we think about a questionnaire, we think about a group of questions, and it's tempting to think of those questions as the things that are the measures, but they're not. The measurement is actually not made at the question level, it's made at the underlying latent trait level. So the latent trait is a concept that all the questions relate to. So in a well-designed questionnaire, you should have all questions correlating to a single underlying latent trait. And this is what really matters, and we need to choose carefully what trait it is we want to measure. There are lots of different traits we can measure, but the master latent trait is something called quality of life, not quality of vision, quality of life. Now, there's a complex WHO definition, but basically in terms of health, what we're talking about with quality of life is every way in which a person can be affected by their disease or its treatments is an impact on their quality of life. And quality of life is made up of many different dimensions. I'll go into how many momentarily, but in ophthalmology, we tend to measure we measure quite a few, but the two we most commonly measure are functioning, which you could also call activity limitations. For example, you're having trouble with something like reading, or we might measure symptoms like, are you experiencing blur? Now, where people get confused is that these things are obviously interrelated. Someone experiencing blur may well be having trouble reading, but what you're measuring depends upon what you ask. If you ask, are you having trouble with reading, then you're measuring functioning. If you ask, are you experiencing blur, then you're measuring symptoms. What makes the whole thing even more confusing is there are a lot of bad questionnaires out there that muddle up different traits within the same measure, and this provides confused or nonsense results. Now, my main research activities is as leader of an international project called the Item Bank Project. This is a project to develop comprehensive measurement of quality of life across all eye diseases. The reason I bring this up is that we've done hundreds of interviews and focus groups of people with different eye diseases, and I can tell you that consistently across eye diseases, there are 12 domains of quality of life that are important to people. One of those domains, you can see all the domains listed here, one of them, fifth on the list, is visual symptoms, and that's quality of vision. So I'm simply making the point that we want to measure quality of vision today, but that's just one of 12 important domains of quality of life for people with eye diseases. So that's what we want to measure. Let's talk about how well things are measured. There's lots of different PROMs out there, and their quality can be stratified into 3 different generations. There's a lot of what's called first generation PROMs. So here's one I developed 25 years ago. It's called the Visual Disability Assessment. And you can see it's just a list of 18 tasks that people may have difficulty doing, and people rate their difficulty. They got 4 choices of difficulty level, and each of those is assigned an ordinal value. And people make their selection, and then the corresponding ordinal values are added up to produce a score. This is called summary scoring. Now that seemed like a good idea at the time, but it's actually highly problematic. It's problematic because if you think about those 18 tasks, they all vary in difficulty. There's 2 driving questions there, one driving during the day and one driving at night. Now we all know that driving at night is a more difficult task, yet the score is worth the same in the questionnaire, and that makes no sense. You know, different tasks of differential difficulty should be scored accordingly. Similarly, you've got those 4 categories with those ordinal values that suggest that these magically sit equidistant on some underlying scale, and of course that's unlikely to be the case. So both of these errors of estimation introduce noise into your so-called measurement. So really this isn't interval measurement, it's more likely to, or better considered as rudimentary information. So the problem with this is you can't use parametric statistics to validly compare these data in terms of change or correlation. Fortunately, there's a very simple solution to this problem in the world of item response theory. A simple algorithm called Rasch analysis, which is based on probability, can estimate the location of both people and items on the same interval scale. And that's shown in the cartoon on the right. We've got items ranked from easiest to most difficult, appearing at different positions along this ruler, and people also ranked. So by applying Rasch analysis to this normal looking questionnaire data, you get true interval scoring, and this enables parametric statistical analysis. So the use of Rasch analysis or another IRT model to generate interval scoring is the hallmark of the 2nd generation of PROMs, and these are clearly superior to the 1st generation. Now there are lots of actually really good 2nd generation PROMs available in ophthalmology today, and we've reviewed those, as you can see here, and depending on what your disease of interest is, you can see recommended PROMs for use. Now there is also a 3rd generation. I won't go into this too much, but basically the big problem with standard questionnaires, even if they're 2nd generation, is they're short, and they're short because we want to implement them in a busy clinical situation. But with a short questionnaire, you're going to get floor and ceiling effects, and that hampers your statistical analysis. So in an item bank, you have a very large number of questions, so you can measure the full range of a trait free of floor and ceiling effects. But because you've got a lot of questions, you can't ask all the questions of a person, so you need an algorithm for implementing those questions. And if you use an adaptive algorithm, you can tailor the questions to the person and get highly precise estimates with very small numbers of questions. So this is a superior approach again. Now let's move to quality of vision. Now, even below 1st generation, we have just rudimentary questions. So there's a lot of papers in the literature, in the cataract and refractive surgery literature, where you've got really just a non-validated question that some clinician has made up. Might look something like this: do you experience glare? And they've come up with a bunch of categories like you can see there. And this is in no way measurement. This is just documentation of the presence or absence of a problem. And that's fine. Look, that has a role. You know, the frequency with which a symptom may occur would be useful, for example, in a safety study, particularly if it never occurs. But there's no score here, there's no measurement, there's no potential for statistical analysis. So it depends what you want to do. Most of the time we want measurement, so this really isn't adequate. Now, moving to the 1st generation level, there are an awful lot of 1st generation questionnaires. Some of these are pretty poorly validated, others are pretty thoroughly validated, like Prowl is pretty thoroughly validated, but it has other problems. But fundamentally, all of these instruments have the problem of they don't provide interval scoring. So you're really unable to establish true measurement, and you're unable to use the scores for statistical purposes. There's only one second generation instrument for the measurement of quality of vision, and that's the creatively named Quality of Vision Questionnaire developed by Colin McAlinden. So I'm going to focus on that for a few minutes. It's a pretty straightforward instrument. It's got 10 different visual symptoms that people get asked about, and they get asked in 3 different ways. They get asked about the frequency with which they experience each symptom, how severe the symptoms are, and then how bothersome they are. Now, this is an interesting approach because you end up with 30 questions, but what's been shown is that the scores on each of these scales are not predictable from each other. So one can frequently have a symptom but not be bothered, or infrequently and be very bothered, and so on and so forth. So they each provide useful information. So this was really designed to be a comprehensive assessment of quality of vision rather than, say, specifically looking at positive dysphotopsia. And it was developed on people with various types of refractive correction, intraocular lenses and cataracts. As stated, it's scored by Rasch analysis, so it gives you proper true interval scoring, and it's been thoroughly tested for validity and reliability, as well as being well studied in a lot of different conditions. I've always liked this figure of LASIK outcomes measurement with the QOV, and you can see that in the 2 weeks after LASIK, you've got this big increase in symptoms, higher score being worse on this instrument, which disappears pretty quickly after 2 weeks once that damaged epithelium is replaced by healthy normal epithelium, and you end up with better quality of vision than preoperatively afterwards. Of course, it's been looked at in cataract, and you see massive increases in quality of vision with cataract surgery and monofocal IOLs, as you'd expect. Now, perhaps of more interest to the people attending this section, there's been some really good recent studies looking at different near correcting intraocular lenses. Nice study here by Dan Tran et al. Looking at an EDOF lens versus a trifocal lens. And you can see in this figure in the top right that the median and interquartile scores between the 2 different lens types is really comparable. But if you dig down into the detail, really it's the starburst question that show a difference between the lenses, and interestingly, it's the EDOF lens that performs worse than the trifocal lens. Another similar study out of Portugal, looking at 2 trifocal intraocular lenses versus an EDOF lens. And again, you can see similar quality of vision for the 3 lenses there in terms of frequency and severity, but the Symphony lens the EDOF lens performs worse in terms of quality of vision, in terms of bothersome visual symptoms compared to the 2 trifocal lenses, which I think is a very interesting result. More recently, out of the Netherlands, Natalia Makhokina with Rudy Knights and a team has developed a negative dysphotopsia supplement for the QOV questionnaire. So that's a useful addition for looking at these intraocular lenses that lead to this problem of negative dysphotopsia. Now, there is a 3rd generation potential measurement of visual symptoms, although it's not available yet. As part of our item bank project, Hamal Kandel led the refractive error module development, and there are 12 domains of quality of life that are measured with this instrument. One of those is visual symptoms, and this domain has 27 visual symptoms questions. So this is really by far the most comprehensive assessment of visual symptoms that exists to date. We follow the same approach we use with the QOV of measurement of frequency, severity, and bothersomeness, and this is implemented via an adaptive algorithm, and should be available in the relative near future. So if I can just wrap up, I think, to me, the situation's clear, both in terms of clarity of the trade under measurement and the quality of measurement. The clearly preferred instrument for use today is the quality of vision questionnaire if you want to measure visual symptoms. But in the future, I'd really like to see an item bank developed for cataract or lens surgery, which incorporates all of the issues that arise in IOLs that correct at multiple focal distances. Thank you.
Thank you so much, Conrad, for a very interesting presentation. So the floor is now open for questions from the audience.
This seems like really useful stuff. Are these things available that we can get access to these things? Is there how do we access these different ones? You mentioned the lesson's not quite available yet, but what about the other?
Look, QOV is available. It's widely used. It's been published. It's open access. If you need support with the analysis, Colin McAlinden's always happy to provide that, as am I. So there's people that can help, but it's a pretty straightforward thing to use, readily available.
I can give you an anecdote about how a poorly designed survey can affect someone's life. My elderly mother-in-law, we took her in for evaluation for cataract surgery. She was 96. We knew she needed cataracts. They asked her, they had a survey, a questionnaire, but to see if you were eligible. The first question is, do you have any trouble driving? She wrote, nope, no trouble driving. I haven't driven in 15 years. And do you have any ever trip or fall? And she says, nope, never, but we've watched her look at a shadow and feel with her foot to see whether or not it was a step. So, you know, based on how the questions were worded, she was not eligible for cataract surgery. And so, you know, a poorly worded questionnaire can have an effect on people's lives.
Oh, absolutely. No question.
Conrad, that's fantastic work. How long does your questionnaire take for the patients? Time
the QOV, yeah, I wish I had that data right in front of me. We certainly measured it, but look, it's of the order of 7 or 8 minutes if you do all three sections. You don't have to do all 3 sections. It depends what you want to measure. You know, one of the advantages of that the questionnaire design is, you know, you're asking exactly the same format of questions repeatedly, so people are able to answer very quickly. You know, questionnaires where you chop and change how the question is asked and the number of response options, and you know, that's where things can go very slowly. So it's not necessarily number of questions, it's also some design attributes that affect time to answer.
So did you do focus groups to sort of understand the language that the patients use when you were designing these?
Always, yeah.
Yeah. So in the talk we're going to give.
It's absolutely critical to have patient input. You know, if you don't have patient input, and you need to purposively sample a spectrum of people that you want the instrument to be relative to. As smart as clinicians are, we just don't know what matters to people because we have our own filters and people use filters when they talk to us. You know, you need to be able to capture that information direct from patients.
Yeah, the language is important, and you know, one of the things I'm going to give a talk a little bit later, but one of the issues is when you switch from one language to another, how do you adapt that questionnaire? So I imagine you'd have to do a focus group. Let's say if you're switching from English to Spanish, you need a focus group series just to validate that.
Yeah, look, there's a pretty well-established process for linguistic validation. But even when you follow the appropriate, forward and back translation, reconciliation, progress, and all that, it is absolutely amazing how things lack cultural relevance. So I'll give you an example. So CatQuest was developed in Sweden, and when it was translated into Danish, now Danish, right? Danish, Swedish. I mean, how close can you get? You can drive over the bridge from one to the other. 2 of the questions were dysfunctional. Swedish questions were dysfunctional in Danish, 2 out of 9. which is absolutely staggering. But there was an explanation for this in terms of you know, the different activities that people do in different countries.
Interesting. Thanks.
Okay, great. Thank you so much, Conrad. And if it's not too late for you, I think we'll have a discussion at the end where, you know, we can revisit some of these questions. So we now move on to Joana Barcala. Joana comes from Two Eyes Vision and the Institute of Optics, Visual Optics and Biophotonics Lab in Madrid, Spain. And she will be talking about a new metric, the multifocal acceptance score to evaluate vision, the MAS metric. So thanks so much, Joana. The floor is yours.
Oh, yeah, sorry, I didn't find that button. Okay, so thank you, Susanna. Thank you very much for the introduction. Yeah, I'm going to present you this new metric called the multifocal acceptance score to evaluate vision, what we call the MAS metric. So as all we know that it's possible to experience presbyopia corrections thanks to visual simulators as in VisEcho. That is this simulator here in the picture, this wearable, see-through binocular with a wide field of view and programmable. And this simulator allows testing multifocal and need of corrections, monovision, or any kind of lens combination. So a frequently asked question is whether a patient will accept multifocal correction. So while this is something that can be tested preoperatively with visual simulators, however, the standard methods to assess visual quality are visual acuity, that not generally includes multidimensional aspects of vision, or defocus curves that are time-consuming, and questionnaires that relies on the patient, on the memory of the patients, and are generally performed after the implantation and after the fitting of the lens. That's not be the best methods to assess that. So we have recently presented this multifocal acceptance score to evaluate vision that offers a rapid assessment of vision. This metric quantifies the image quality of the patient in a wide variety of visual scenarios with different illuminations, distances, contrast, and glare. And well, these are the set of images presented at far distance, normally for meters, both for daylight and nighttime conditions. And we put a real bright white LEDs on the top of the car headlights to introduce real glare. And here we have the set of images for near distance, shown at 40 centimeters that are representative of different visual tasks during day and night illuminations. And well, the multifocal acceptance score to evaluate vision is graphically represented as a polygon like this one, where the vertices are the measured stereopsis and the perceptual score given to the different conditions. So patients have to give us perceptual score between 0 and 10 based on their perceived visual quality. And here we have, here is nicely illustrated in this example of a patient. We can see how we can see difference between corrections, for example, at far distance being the best with the monofocal correction, and the improvement of the near with the other presbyopic corrections, and for example, how the stereo vision is preserved in this case with the bifocal correction. So, but prior to perform a MAS metric measurement, we need to set the scale criteria by showing the patient their best and the worst image quality to set the higher score a 10 and the lower score a 0 they can have. So I'm going to show you some results from different studies. This first one was performed in 5 subjects with paralyzed accommodation and 5 presbyopes. So the tested corrections were monofocal in both eyes, bilateral bifocal corrections, a monovision, and a mix and match with a monofocal far in the dominant eye and a bifocal lens in the non-dominant eye. And the corrections were simulated through the same VisGecko, but also tested with fitted contact lenses on the young subjects. So with the MAS, we can analyze how a presbyopic correction degrades the far vision compared with a monofocal lens and how the near vision is improved. So here in this graph, we can see the visual compromise between both the degradation at far distance and the visual benefit at near distance. And also really important, we can analyze how is the visual compromise between the near stereo vision and the visual benefit at near distance with each correction. We can integrate all these metrics together to generate an overall visual quality metric. And we can also compare corrections in terms of the consistency of vision they produce at different distances, showing, for example, here a higher imbalance for the monofocal far vision corrections and a better overall quality for bifocal and monovision, depending on the subject. So moving to another study, in this one, for example, 27 subjects evaluate their quality of vision with the mass metric. The visual acuity was also measured, and they respond questions extracted from the clue questionnaire. So in this study, the tested corrections were 3 different editions of a multifocal contact lens, both simulated with the Simbis Gecko simulator and fitting on eye. So here we can see the logMAR visual acuity with the mass, in the same graph with the mass scores for the contact lenses in blue and the simulated in orange. So they were not correlated at all at far distance. And regarding the near distance, they were only correlated for the simulated lenses. So we can say that generally the visual acuity do not correspond to the perceived visual quality of a patient. And while this slide shows the question extracted from the clue questionnaire related to the satisfaction at far distance, and in this case, patients answered the questionnaire in the clinic just after the removal of the simulation or of the contact lens. So the answers of this questionnaire were highly correlated with mass scores. As we can see here, the blue asterisks are from the contact lens and the orange for the simulated lenses. And we repeated this for the near distance questions and also for the satisfaction questions regarding night illumination. And both of them were highly correlated with the mass score. So we can say that when a patient answers a questionnaire right after feeding, so their answers are highly correlated with the mass scores they give while they are seeing through the correction experience in that moment. And well, this other study was performed with cataract patients. So we measured 24 cataract patients with a really large OC index, that is the objective scatter index for cataracts. And 15 of them were also measured after the bilateral surgery of and the implantation of monofocal IOLs in each eye. And they analyzed their perceived visual quality both pre and post-op with 4 presbyopic corrections, the monofocal far in both eyes, the bilateral bifocal corrections, monovision, and a mix and match with the monofocal on the dominant and the bifocal on the non-dominant eye. And in this case, the mask was performed only during daylight conditions. And we include an intermediate image, as we can show, we can see it here. This is the intermediate image we include at 64 centimeters. And we correlate the perceptual score with the OC index, that is the objective scatter index I told you, and quantifies the cataract level. So we obtain that the perceptual score decreases with increasing OC index for most corrections at far distance, as we expected. But however, for intermediate and near distance, the monofocal far correction increases with the OC index, the correlation between them. So this could be explained with an increasing blur tolerance with higher scatterings. Analyzing the visual degradation at far distance, we found that it was constant for all presbyopic corrections regardless of the cataract level. However, the visual benefit at near distance is produced only for patients with an OC index lower than 5. So when we measure both the patients after the cataract surgery with the monofocal IOL implanted, here we can see the perceptual score of both sessions, pre-op and post-op. And we can see that patients rank in the same order with the opacity of the cataract and with the monofocal intraocular lens implanted. And the scores, of course, were higher after the cataract removal. To analyze these trends a bit better, so we obtained that the scores given with the cataract and the scores given with the intraocular lens are highly correlated for all distances except for near distance, that it is correlated if we remove the far distance. So maybe for that, increase of the correlation of the scores with increasing OC index. So we can say that subjects are accurate at ranking the perceptual quality of the images with different corrections, even through a cataract opathification. So to conclude, we can say that the MAS is a multi-component metric that evaluates the perceived visual quality of scenes that patients can recognize and are important or on their daily visual tasks. But the MAS do not rely on patient's memory. It allows to experience the perceived visual quality. This metric, in combination with the SIMBIS-GECO simulating post-biopic corrections, allows a comprehensive and rapid assessment of vision before IOL implantations or contact lens fitting. The MAS can be performed in any kind of presbyopic patients and also with cataracts, and different subjects have different preferences on the presbyopic corrections, suggesting the need to evaluate the visual experience before the implantation. So thank you so much. And if you have any question, I open to you.
Thank you so much, Joanna. We have time for a few questions. Dan may have a question. Go ahead, Dan.
It's a good presentation, but you've got me stumped for once for questions.
I can let the audience think for the end of the
Yeah, and I guess this is I mean, there is a question that we may bring after the entire session, which is what we are targeting. Are we targeting the perceived visual quality of patients? Are we targeting how well they can do a certain task? I think this lack of correlation, or necessary lack of correlation of visual acuity with visual performance or visual perception of natural images, I think it's a good and interesting result to just think about vision as much more complex than just looking at visual acuity, right?
Yeah.
Okay, no other questions? Okay, so maybe we can move to our latest presentation. This is Scott McRae. Scott McRae is refractive and cataract surgeon and faculty member at Flower Eye Institute and Center for Visual Science at the University of Rochester. And he will be discussing the project he's been involved for a number of years now on presbyopia correction patient-reported outcomes. Scott.
Yep, coming on. Thank you. Let's see, I need to go back. Sorry. I need to back up here. Okay, good.
Here we
Good.
go.
Yeah, sorry. We rehearsed and then I forgot to rewind. So I'm going to talk to you a little bit about a large study that we've been doing, and it's the assessment of preoperative requirements and outcomes after presbyopic cataract IOL surgery. And this is primarily the preoperative information, although we have a little bit of postoperative information for you. This is a large study that was done at the request of the FDA and the industry. It was done in conjunction with the American Academy of Ophthalmology, helped coordinate it. The RAND Corporation actually ran the study, and the University of California UCLA biostatistics group worked with us as well on this particular study. So we also worked in conjunction with industry. The advisory committee charter was the development of a patient-reported outcome measure for premium IOLs that would support device applications and other regulatory-related activities for FDA and other regulatory groups, as well as aiding research and quality improvement activities. It also was coordinated basically from invitations to all the companies, and a number of companies responded and participated to the invitation. And periodically we reported our progress at the annual American Academy of Ophthalmology meeting. The American Academy of Ophthalmology Hodgkin Center served as a neutral convening body, and FDA served as on an advisory capacity for the study. These are the advisory committee members. The clinicians from that were selected by the Academy included Sam Mascott, myself, Jack Holliday, and Walter Stark. There were other people with extensive clinical experience also on this committee. It also involved some really outstanding people from industry, as well as the FDA staff that was involved with this, helping us throughout the entire study. Well, why do we do this? Well, there were no large standardized validated systems that FDA and industry could use to meaningfully measure premium or standard IOLs. And by standardizing and validating a metric, we can actually compare our patients' subjective responses to monofocal and presbyopic IOLs, both pre-op and post-op. Currently, the industry, each company is basically doing a different study questionnaire, and so this is an attempt to actually bring this together so that there's a standardized questionnaire that we can use throughout the industry. So the study was organized, and we had 717 patients that completed the preoperative questionnaire. 508 completed the postoperative questionnaire. At the 4 to 6 month interval, we had to extend this basically because of COVID. We extended the collection period, but we don't think that that affected things significantly. There were 20 clinical practices. Almost all these practices had been working with industry. They were high quality practices that industry had used frequently, and very high quality cataract surgeons. The IOLs that were used in the study included bifocals and trifocals, typically the ones that were available for clinical trials studies in the United States. It included torics, EDOFs, and the monofocals were the control lenses typically that were used by those companies that did these premium IOLs studies. So these are primarily the preoperative data. We're, as I'll mention later, we're still collecting and analyzing the postoperative data. So I'm primarily going to talk to you some about the preoperative data that we got and the trends that we sort of sorted out. And I divided this into, well, actually the way the questionnaires were designed, they asked about quality of vision. Most patients reported either poor or only fair quality of vision, about 84% total. 36% noted poor vision, and 48% noted only fair vision. When we asked about satisfaction with vision, it was very similar to the visual quality question, and that was 83% were very dissatisfied or somewhat dissatisfied, with 48% being completely dissatisfied and 35% being somewhat dissatisfied. This was the reference image that we used. We have to thank Gun Young and his team at the University of Rochester. This is actually done on site at the University of Rochester. A couple things about this reference image. You'll notice that you can actually see on the bus on the lower right, you can see the back lights, and there are two. Similarly, the two yellow lines in the road. So there's pretty good high resolution, high definition with this reference image, and we used this and then modified it for the patients to demonstrate various visual symptoms. So this was the demonstration of halos, and on the form you'll see it asks in the last 7 days, how often did you see halos? Never, all the way to always. When did you see halos in the last 7 days? Only when wearing glasses or contact lenses, so we distinguish that, or only when wearing contacts, or when wearing and not wearing glasses or contact lenses. The next question, at what time of day did you notice halos in the last 7 days? During the day, dusk, or at night? How severe were they? Mild, moderate, severe? And how much were you bothered by the halos in the last 7 days? Not at all, a little, somewhat, quite a bit, and extremely. So that was sort of the standard, one of the standard pages for each of these different images that we went through. When we went through this, and I'll show you some of the images as well in just a second, there were two prominent symptom groups pre-op. I call this the blurry vision group. It included blurry vision, which was present in 67% of the pre-op patients prior to cataract surgery, and 65% noted hazy vision. The second group that we had that really was dominant was the glare group of symptoms, and that had the highest prevalence at 83% of all patients that were surveyed, with starburst and streaking, halos and snowballs all being part of that symptom group. So here's a demonstration of the blurred vision. You'll notice that there's a loss of high spatial frequency. And I should back up and just tell you that, like we were talking with Conrad earlier, we did focus groups asking patients when we showed them these images, how they would describe it. And they described this as blurred vision, basically. This is in contrast to the hazy vision, where the patients describe that as hazy or foggy. But you can still see some high spatial frequency in that particular image. You'll notice that the center line has two center lines, and the bus has two rear lights on as well. Patients describe this as hazy or foggy vision. So in the blurred vision group, either blurred vision or hazy vision, blurred and hazy visions were symptoms most prominently associated with dissatisfaction and worse vision, and most noticeable during the daytime compared to nighttime. Pre-op, overall, 67% of patients noted it when surveyed. Post-op, interestingly, 22% of the patients actually noted it post-op at that 4 to 6 month interval. And this was a 45% decrease in their symptoms. But interestingly, for a clinician like me, there were still 22% of patients that did notice some blurry vision symptoms, which is interesting because it sort of teaches me that as a clinician, you don't want to promise that all the visual symptoms that patients are going to have are going to completely disappear. I think that's one of the teaching points of this in this exercise for me, actually. Now, this is the glare group, and we divided this into snowballs. Each of these images were actually presented separately and then as a group. Snowball is in the upper left, halo is in the upper right, starburst is in the lower left picture, and streaks are, those are horizontal streaks in the lower right. And in the glare group, which included starburst, snowballs, halos, and streaks, there were over 500 patients that noted this. It had the interesting thing is relatively low frequency of symptoms during daytime condition. Less than 10% noticed this as a problem during the daytime. But just like Dracula, it comes out at night. It had a high frequency of symptoms at night, 77% starbursts, similar percentage with snowballing and halos, dominating all of their symptoms at night. The pre-op to post-op change, 83% noted pre-op that there were symptoms, But post-op, 36% of patients actually noted some glare symptoms post-op. But there was a 47% decrease in those symptoms after cataract surgery at that 4 to 6 month interval, roughly. So, but it was interesting to me, again, as a clinician, that 36% of patients still noted some degree of glare. It'll be interesting when we dig down into that data a little bit more, how much that glare was bothersome or really hurting them. So in the blurred vision group, as I mentioned before, blurred vision and hazy vision were symptoms most prominently associated with dissatisfaction and worse vision, and most noticeable during the daytime compared to nighttime, whereas in the glare group, as you can see here, these were relatively low frequency during the daytime, less than 10%, but high frequency during nighttime. And there's the glare group again. Now, there were other symptoms that patients had, and we also did the dysphotopsias, but I don't have time for that. But one of the common ones was floaters, and this was sort of a confounding symptom for patients because many times it's present before surgery, and we worked really hard to give them a wide variety of floaters. There's lots of fighting, and Gunyang was very kind in terms of moving these in and out so people could agree or disagree which ones were common in the population. But there's a multiplicity of different images for floaters, and this helps capture some of the really common ones. It was the next most common symptom, 49% at baseline, and it was reduced at nighttime, only 23% noted floaters. The severity of the floater symptoms, however, was less than glare or blurred vision, and it was less bothersome as a symptom overall, both preoperatively and postoperatively. One of the other more problematic symptoms was double or multiple images preoperatively. It was less common, but when it occurred, it occurred in about 27% of patients, but when it occurred, it was usually associated with either moderate or severe bother for the patient. So when it happened, it wasn't well tolerated. So in summary, in terms of the preoperative data, blurred vision, either blurred vision or hazy vision dominated the symptoms during the daytime. In the glare group, starburst, snowballs and halos, as well as streaking, dominated symptoms at night. The pre-op follow-up data or the post-op follow-up data we hope to have available within the next few months to make it possible to look at the change from pre-op with our baseline data. I think it's going to be really, really interesting data, and we hope to get this study completed relatively soon. Thank you.
So much, Scott. Very, very interesting and informative, and sure we'll stay tuned to more to come. Questions for Scott?
I have one this time.
Okay. Go ahead, Dan.
Hey, Scott, good presentation. I was looking at your simulated images. Were those generated with actual aberrations, or try to simulate the physics of things, or are these just kind of Photoshop kind of things?
You'll have to ask Gunyang how he actually did that. I think they sort of worked on. I can't answer that directly. I'll just
okay.
Say
Yeah, they don't look like some of the aberrations, like keratoconus is a real strong coma signal, which gives you like a tail on points in those kinds of things. And so some of these features are a little more distinct. We did a survey some years ago trying to do some simulation of these. We surveyed day scenes and night scenes. There's about 2 orders of magnitude in a daytime scene from darkest to lightest. In a nighttime scene, there can be 7 orders of magnitude. So it's somewhat difficult to even take any kind of image that has that range. Even high definition cameras can't really record that level of range. And so it's fairly difficult to simulate these things accurately. So it may be just as well to do the surveys and just do it with Photoshop and say, is it something like this?
Yeah, we went back and forth and back and forth. There was a lot of discussion. Poor Gunyang had his super patient with us going back and forth and modifying these images. We also did dysphotopsias, the positive and negative dysphotopsias. We had nighttime dysphotopsia images too that I just didn't have time to present in a spider web type image for the EDOF type. And that was included in the survey. So it'll be really interesting to see how that all kind of shakes out when we compare that for the patients pre and post.
Yeah, and I guess this is all very interesting, right? And there was a question before to my Wester, it's to what extent the simulated images by computer simulations represent the real world. And I think one of the challenges for, these really high ranges of luminances that may occur at night with a bright source of light, whether it's a simulation on the screen is able to capture. And I believe this is why the mass scoring, it has actually superimposed light sources on top of the headlights of a car to actually recreate that impression through real lenses that you put in the simulator.
Right, it is more dynamic, and I have used the Simbus, and I literally walked out from the office and looked at it and turned car lights on and was able to actually simulate it. So it does give you a much more organic feeling for how that occurs. And one of the challenges of doing these types of surveys is you have to present them something if you want them to understand what the question is.
Mm-hmm. Yeah, and the terminology that can get confusing with so many terms, right? For education. So more questions to Scott before we open it up to a more general discussion. Okay, so I've seen Conrad has been very busy answering some questions in the Q&A. And I understand there's connections between the type of questionnaires that Scott has been presenting for patient-reported outcomes and those in Conrad's questionnaire. So I'm wondering if you can make a comment on maybe Conrad on how your questionnaires link to the patient-reported outcomes that are more specifically targeting premium IOLs.
That took a left-hand turn, that question. I thought you were going to ask me something else. I presented some results with premium IOL, so I thought that was pretty clear. I think it's worth commenting on the difference between what I was talking about and what Scott was talking about. Everything that Scott presented, he really just talked about the percentage rates at which things were observed, and that's not measurement. That's just documentation of rates. Now, if that's what you want to know, then that instrument's perfect for that. And it's got great content and it's got nice images, and I'm sure people find it easy to answer. And so for documenting the rate at which things occur, terrific. Now, I'm more interested in measurement. I'm more interested in can you end up with a metric that scores quality of vision, and that's what QIV is good for. And that's all the work we do with the item bank is around developing scores, measures for each domain of quality of life that we're interested in. So the scores are much more valuable because you can do all your parametric statistical analysis with them. You can calculate change, you can calculate correlation with other variables, you can explore relationships that might teach you something about causes or making diagnoses or whatever it is you're trying to achieve. So measurement is the ultimate in patient-reported outcomes. It gives you the power to do all sorts of things. So that's why we pursue things in the way we do. And I talked about the technology that I talked about. And so that's useful for outcomes research, but it's also useful just to document stuff as Scott's done. And I don't know what else that instrument can do, but it looks to be very good at documenting the rates at which things occur. So that's terrific.
Great. And I see now in the chat there is a number of questions for Scott. So there is one by an anonymous attendee. Can the prompt that was used pre and post-op and or as well as the details of the development available be shared? Okay, so I guess the question is about publication of these results, Scott.
Yeah, you know, as I mentioned before, this whole process got very slowed down by COVID. And so once we get this data analyzed, and we're going to shrink down the questionnaire so that it's more manageable for industry, then we're going to be publishing on this. There'll probably be a series of publications on it in ophthalmology through the American Academy of Ophthalmology.
And there are two questions. One is on the impact of post-op refractive errors in the outcome of the questionnaires.
Yeah, that's a really important question that we had to go back and actually collect some of that data to make sure that that was part of the analysis. And that's one of the things that actually slowed us down, but it will be included. Mm-hmm. As well as the type. The approach is not to sort of isolate individual intraocular lenses, but to look at, to create a metric and to look at the trends and be able to allow the industry to compare apples to apples and oranges to oranges, rather than having all these different questionnaires. Mm-hmm. And then have it validated.
And there's another question, which is, I mean, you're talking about halos and blur vision, and presumably this all refers to far vision. There is a question here on the survey, potentially including near vision.
Yeah, the survey does include on that page, the page that I showed you, it has a question on with near vision. Mm-hmm. So it does include near and intermediate vision.
And I think this is one question here on adaptation that I think it would be interesting to get both Mike Webster and your perspective. So the question is, to what extent does post-op follow-up has on running the questionnaires in terms of visual disturbances adaptation? Would you get the same result 1 month versus 5 months post-op?
Let me answer it in terms of the study. We deliberately didn't want to get. we had plenty of data to work on, and I think the advisory committee was more interested in that 3 to 6 month data, because exactly the first few months there's a lot of symptoms that patients get that eventually subside. And I think long term, we're mostly interested in how the patients are going to fare in the long term, and you know, addressing the early pre-op, the 1 day, 1 week, 1 month earlier periods. Those we just didn't have the bandwidth to do that type of extensive study. And I don't know that industry wants to get into that level of detail as well.
Mm-hmm. So if Mike is still in here, I mean, that would be an interesting question for him. I mean, normally when we talk about adaptation to spatial features of the image, I mean, it's either contrast or even distortions. But Mike, if you are here, what is your feeling about this type of visual disturbances that occur in particularly premium models, where you would see halos or these visual disturbances that are not that typical of just a blurred image, but other types of features?
Well, I think I've never really found anything you don't adapt to. So I think definitely people will adjust to that. And I just want to say, I think that a real value of these questionnaires is to be able to track things like the long-term adjustments that people are making. It's very hard to keep bringing people back in for clinical studies and things, and to have something where they can be monitoring their own vision over time through something like the questionnaire, I think is incredibly valuable and is going to give us a really rich source of information that we currently don't have.
Mm-hmm. Yeah, I guess one of the general questions for the four of you is, I mean, what quality? I mean, we're targeting the visual quality, right? And what do we mean by visual quality? I mean, do we mean? I mean, having a good visual quality is the absence of these visual disturbances. Is it responding well to a series of visual tasks, or is that the subjective impression of the patient of you know, being satisfied with the vision, or judging the image as sharp, right, as a natural image. So what do you think the questionnaires are really targeting, or what do you think the patients are really answering when they respond to the set of questions in these questionnaires?
I can tell you as a clinician, all of the above. And we tried to design the questionnaire so that we captured all of these things that, you know, the near vision, the intermediate vision, the distance vision, daytime vision, nighttime vision, vision with or without correction. You know, it's a complex world that our patients live in, and you know, the visual demands vary, as we all know, between, you know, it's a lot different if you're a space technology engineer compared to somebody that is just doing landscaping or something. There's just a tremendous variation in terms of how patients perceive things.
Great. We have some questions.
I'd agree with that if I could add. I mean, I think all these symptoms are real things that make sense, and people can perceive them. And what do people respond to on questionnaires? Well, it's their perception of what they're seeing.
And Mike, you have been interested in looking at what specifically the patients are looking in the images, right, to assess their judging of the quality of those images. We have
I have just a comment as a clinician for it, and for Mike and the others, and comrades really address this beautifully with some of his work. But you know, when you add in I see a lot of patients that have or not a lot, but some patients that have multifocals that are sent in, and they have 3/4 of a diopter of astigmatism, and it sort of gets undetected by the clinician, and then they end up on our doorstep. So in one of the big questions for us when we're doing this kind of presbyopic multifocality is, you know, what's that threshold? How much astigmatism can they tolerate? How much higher order aberration can they tolerate? And, you know, I guess that's the big question from a clinical perspective. Why, you know, some patients are asymptomatic and functioning well, and they're super happy with their multifocals, and then other patients come in just complaining bitterly about things that they're not that dramatically different than the patient that that is very satisfied with the lens. I think that's the real challenge for us in the clinical world.
And Mike, do you have any comment there?
Well, I was just going to add that I think a really important dimension to things like visual quality is what people actually notice and how salient a given artifact is, for example. And again, I think that's something that's really important in understanding adaptation that hasn't been looked at enough, is not just changes in sensitivity, but how much you actually notice things around you. And again, the adaptation, you know, if you're used to seeing a particular artifact all the time, then over time that will lose novelty and you'll become sort of less aware of it, I think, in some ways. And when you add a correction, the things they're going to specifically notice is exactly how is my vision changing relative to what I've been adapted to. So that was kind of a long, vague answer. But anyway, I think in terms of thinking about quality and even sort of understanding individual differences, it's important not to just assess the magnitude of the artifacts, but sort of the perceptual salience of them to a given individual.
Mhm. Great. So we are close to our allotted time, but we have some questions from the audience. If they're still there, I would like them to just speak up. Ron Kruger, you have a question on EDOFs and multifocals.
Can you guys hear me?
Yes.
Okay, yeah, no, I think the biggest thing is seeing the questionnaires, seeing what Conrad said a little bit about how maybe the symptoms with EDOFs can be a little greater than with trifocals. I just want to kind of hear it from Scott's perspective and from the rest of the group of what they're sort of seeing, what patients are reporting with regard to the various visual symptoms and the different multifocal IOLs that are being implanted. You know, can we get some kind of trends that develop to sort of understand better, you know, where the compromises might be greater? Because we all kind of know what the lenses will do in terms of giving range of vision. What we'd like to drill down on more is what are the compromises, because that's the stuff that we want to be able to disclose to them when we're discussing options.
Yeah, what I can tell you is that when you combine the visual simulators that can simulate EDOF lenses or multifocal lenses, and you can actually do that on the same patient, and like post-operatively that you have what you have right after your lens is implanted, you can clearly see differences in the through focus curves on that on a given patient, different multifocal acceptance scores for near, intermediate, or far. So you can really assess differences that are, they match what you expect from the lenses, but they have individual differences, which depend on various factors on the patients, including their own aberrations and other neural factors. And I don't know if Scott has run the questionnaires on different groups of patients.
Yeah, well, it's a pretty extensive, it's a very large study with a wide variety of different types of lenses. So we should be able to get an understanding of that. One of the questions is, with an EDOF, you do get probably more haloing or spider web image or whatever. We don't have that data yet, but you probably get that not infrequently. The real question is how severely is it affecting their subjective satisfaction and their visual quality as they rate it in their own words. The questionnaire will help us, because of the way it's designed, it will allow us to look at that in terms of severity. You may have a high frequency of symptoms with a particular lens, but it's not bothersome. The floaters were similar to that, where they were just sort of a confounding variable, both pre-op and post-op. They're not necessarily caused by the cataract surgery, although they do happen a little bit more frequently after cataract surgery. But we wanted to eliminate that. But they were not associated typically with real severe disabling type symptoms. So I hope we will be able to get that information, just like you asked, Ron.
Yeah. And just to finalize, there's two somehow technical questions. One is from Derek Nankiville. I don't know if you are here and can ask directly. Derek?
Oh, look at that. Yes, right. I guess I was really getting at maybe Dan kind of asked about this, Scott, and under the hood of the simulation and just thinking about the role of spectral composition of the stimulus. And so my take was that, that's not something that the simulation tool can handle in terms of generating those images, but maybe just to get a broader feel for what the committee thinks around the role of spectral composition on things like snowball, starburst, halo, and streaks.
I guess in combination with chromatic aberration, right?
Right.
Scott, do you have a an insight
Well,
on
I'd
that?
say that's above my pay grade in terms of being able to explain that. That's not. I'm a clinician, and I don't claim to be able to understand, how Gunyang designed that. So.
Mhm.
Or even if it's not part of that simulator, just a comment around the role of, I guess, scattering and chromatic aberration on these visual phenomena, and whether spectral filtering or spectral composition of the stimulus might influence the magnitude of the effect.
It may, but we were limited in terms of the images, the number of images that we could show, and we had to pick, because of time constraints, we had to pick the images that we felt were most relevant, that patients complained about the most or felt.
And there is no complaint about chromatic effects. People mentioning some chromatic artifact of any.
Yeah, I mean, it's interesting when I've done simulations of polychromatic point spread functions, for instance, you see a lot of kind of rainbow speckle patterns.
Mhm.
But when you talk to patients that have those kinds of aberrations, they never report those.
Mhm. Mhm.
I mean, yeah, I guess my question would be, do patients adapt to that type of pattern? Back to Mike's work,
Mhm.
after a while, they can adapt to that as long as the remainder of the image quality is.
Well, there's almost 2 diopters of chromatic aberration across the visual spectrum,
Mhm.
but we don't notice it.
Mhm.
I don't notice that blue isn't as sharp as red or vice versa.
Mhm.
And so your brain is thoroughly adapted to that. And
Mhm.
in fact, it may be useful in some of the processing that it needs that somehow.
Mike, do you have any comment here on adaptation to chromatic aberration?
Well, again, I think, that's really well established. There's been a lot of studies looking at adaptation to chromatic fringes and showing that we do, and we probably are strongly adapted to the chromatic aberration of the eye. I was just thinking in terms of the spectral composition. One interesting thing is that the lighting we're all exposed to is really dramatically changing lately. So as we adopt LED lights versus you're really changing the spectral composition, especially in the evening. And I don't know what the consequences of that are in terms of trying to simulate the kind of experience people will have at night. But certainly in the field of color vision, there's a lot of interest in what's happening as you go to these much more narrow band spectra, and that really sort of emphasizes individual differences in color perception, and that the industry is now trying to deal with.
Yeah.
And finally, we have a question from Bruce Drum. Bruce, I don't know if you want to speak up. So.
Okay, here, I guess I'm unmuted. When you're trying to create a picture simulating symptoms like halo or something, if you try to make it realistic and use a broad range of luminances, then the patient looking at that will have its own symptoms superimposed on the simulated symptoms. So that may distort the perception and the response. How do you deal with that?
So Bruce, the question is then, I mean, if you are, basically you will have like 2 convolutions, right?
Right.
Or you will be seeing an image through an already distorting optics.
That's really a question for your SimViz, I think, right? Because
Well, it will be for general, right? I mean, if you're showing, your pre-op data, your pre-op images, right, that you're showing to the patients, they're not sharp. They have like the degradation that you impose on the image in your artificial image processing, plus the degrading optics of the patient, right? So.
But it depends on for you're going to show it on the screen, for instance, depends on the field of view and the distance from the screen and the resolution and all those kinds of things of the screen. That image may be much bigger on the screen than the simulated image you're trying to create. So it's
a matter of spatial frequencies, right?
Yeah.
If you're looking,
it is complicated.
And I'll say I've tested amblyopes, and through their amblyopic eye, I can ask them, is the image on the screen focus? And they'll agree with me. So they can recognize through their own visual system whether the world is physically focused or not. And I think, you know, what their own visual system is the way it's going to degrade it is going to depend on whether you're introducing a change that they can actually see. But what if they can see it, I think they're very good at noticing how is the world now different from what I'm used to seeing.
And even I think Joanna can comment on the results of patients seeing the mass images through cataract, through the SynVis, because that's
yeah. So I mean, when they have an optics with any problem or with any opacification or wherever, and they see through it, it's not that much, at least with the multifocal corrections, it's not that much degraded because they are already degraded. So they normalize from their own vision. So
it may be better to use the sort of collapsed contrast images that you would have on a piece of paper for this purpose, because as you increase the dynamic range, in other words, if you look at, if you're out at night and a car's headlights come directly at you, the actual range of contrast may be like 6 or 7 orders of magnitude, and you'll see a lot of a lot of symptoms, a lot of halo or a lot of starburst. Whereas if the contrast isn't so great, you may not see anything other than the actual light. I mean, it's
yeah, not completely.
If the stray light is a factor of 4 orders of magnitude below the glare source, why in most cases you won't see it, but if it's bright enough, you will.
Good point.
Yeah.
One of the things as a clinician that I like about the SynVis is that, you know, you just put in lenses that correct out the patient's, basically correct out the refractive error, but they're looking through their own aberration pattern, their own high order aberration pattern, so they can actually see these. And one of the things I like about the concept is that it's good to show patients the difference or the change, you know, in the trade-off that they get. Let's say if they have a multifocal, because you can definitely tell there's a loss in detail or contrast with something like that. And you know, I think one of the problems we have as clinicians when we give informed consent and we talk about a multifocal versus a monofocal and the trade-offs, even the clinicians they've never simulated it for themselves. So how can they do good informed consent to the patient? And one of the great things about SynVis is and my technicians have tested it too, they actually understand it now. So when they talk to patients, they can tell them what it looks like. And even better, if we had, you know, technologies that could actually simulate it so that, you know, again, like Susanna's idea, that they could test drive it before they actually have an implant like that. That's the big challenge for us clinicians as well. Which lens should we get for, you know, for what patient, and what's the trade-off, and are they going to accept that trade-off?
Absolutely. Okay, I think we could continue discussing for a few more hours. I think that's been a great discussion, great talks. Thank you so much for taking the time and for these wonderful presentations and discussions. Also, thank you so much to our supporting corporate companies and ISOP for their effort to put together these seminars. And I think, as always, really nicely combine science and industry and the clinics. And I think really trying to focus to get the best corrections and the best solutions for patients. Thank you also very much, Daniel, also Chris Morrill and Chris Rodriguez for the technical organization. And well, we see you soon for the next webinar, which is October 20, on unblurring presbyopia through focused communication, which is going to be moderated by Keith Holliday. So thank you so much, and see you soon. Bye-bye.
Okay, thanks, everybody.
Thanks, everyone.
All right.
Thank you.
Thank
Bye-bye.
you.